All right, our objective for today, I can write, identify, and graph parallel and perpendicular perpendicular linear equations. I can write, identify, and graph parallel and perpendicular linear equations. Let's read together. 1, 2, 3. I can write, identify, and graph parallel and perpendicular linear equations. Okay, so we already know what linear equations are. We've been graphing these and solving these and identifying slope and y-intercept from them. Okay. The only thing that we need to look at today is parallel and perpendicular. What does that mean? Okay. And three things that we're going to do. Once again, we're going to write, we're going to identify, and we're going to graph. So I gave you guys what a linear equation is. We already have this. You don't need to write your Freire model. Okay. So we know what a linear equation is, what they look like, what they don't look like, and from there we went from linear functions to linear equations. So write these steps down, please. Steps. 5 steps for today. Number 1, solve for y and write the equation slope-intercept form. Step 2, compare the slopes and intercepts and identify if the lines are parallel or perpendicular. Step 3, identify and plot the y-intercept. Step 4, identify and use the slope to plot points. And step 5, graph the lines. Copy that, please. All right, here we go. Steps. Number 1, solve for y and write the equation in slope-intercept form. I want you guys to notice that steps 1, 3, 4, and 5 we already did on 2 lessons ago when we wrote equations in slope-intercept form. We solve for y and write it in slope-intercept form. From there, step 3, you identify the y-intercept and plot it. From there, we use the slope to plot points, and then we graph our lines. So we already know what to do. The only difference for today, I'm including step 2, which says to compare the slopes and intercepts so that we identify which ones are parallel and which ones are perpendicular. Okay? So, with that said, what to remember? So I want you to circle the word on the first step, solve for y, and the word circle write, slope, intercept form. Solve for y, write, slope, intercept form. Step 2, compare slopes and intercepts, and circle the word identify, parallel, or perpendicular. Step 3, identify and plot y-intercept. Step 4, identify and use slope. And at the end, graph. So with that said, we know what to do. And vocabulary. On the left-hand side of your Cornell notes, on the Q side, I'm going to give you a vocabulary. And on the right side, you're going to sketch this graph. You have your ruler, you have your colors, right? Here we go. On the left side, write, parallel lines are lines in the same plane that have no points in common and will never intersect. That's on the Q side. Parallel lines are lines in the same plane that have no points in common and will never intersect. Here's a graph that you're going to sketch on the right side. There's 2 lines, one in blue, one in red. Next, terminology is perpendicular lines are lines that intersect to form right angles, which are 90 degrees. That's still on the left side. And on the right side next to that, you're going to sketch the following graph. And it should look something like that. So I'll go ahead and leave that up there. And for this one is labeled a 2 got cut off. All right, copy that, please. All right, here we go. Parallel lines. This is an example of parallel lines, and I want you guys to pay attention. Pens down, eyes up here. You're going to miss it. Here you go. What's so special about parallel lines? Let's find out. Everybody look up. Look at this and look at this. Tell your neighbor what you noticed. Okay, so one thing that we should point out is that parallel lines have the same slope. Write that down, please. One more thing that we notice, I'm going to circle it. This and this. Did everybody catch that they have a different intercept? So we'll write it right here. I'm going to do that in blue. Different y-intercept. And let's see over here. Is this blue line crossing at a different point than the red line? Yes, but they're still parallel because they have the same slope. So they have the same slope, different y-intercept. Okay? So far so good, right? All right. So now let's look at the perpendicular lines. Here we go. Everybody look up. Here we go. Perpendicular lines. So we got negative 2/3 as a slope for this one, and this one is 3/2. Look at them. Don't say it out loud. Here we go. Tell your neighbor what you notice from those two things. So I hear a lot of you saying the reciprocal. Okay, that's true so far. That's one thing that they have in common. But the other thing, who noticed this? Everybody look up. That this is a negative, but this is a, so therefore they're called reciprocal inverse. Inverse. So when we solve an equation and it has addition, what is the opposite? Or what is the inverse? Subtraction. So if this one has a subtraction, then the other one should be an addition. But it is the reciprocal. These are known as reciprocal inverse. Example. I want you to write right underneath that, example. And I'm going to give you the number 3. 3. So I'm thinking of the reciprocal inverse of 3. Reciprocal inverse. Think about it, Owen. Think about it. Reciprocal inverse of 3. Okay, Paulina, what'd you get? She got the negative correct. This is a positive, so it's a negative because it's the inverse. What else do we need? Think about it. Okay. All right, David? You said 1/3. And let's see. If this is 3/1, what is the reciprocal? 1/3. If it's a positive, what is the inverse? Negative. That's why it's known as the reciprocal inverse. And so that you remember for next time, when you multiply the two slopes of perpendicular lines, they should give you a product of -1. What is positive times a negative? Negative. If we multiply 3/1 times 1/3, it gives us 1. 3/3, which is 1. Yeah, here's -1. Yeah. Everybody got it? So one thing to remember, once again, perpendicular lines, when they intersect, they make 90-degree angles. Here it is. It makes 90-degree angles all over. However, but the most important thing to remember that the slopes are the reciprocal inverse of one another. Are we there? Yeah. All right, let's continue. So with that said,
So, Mr. King, if you're looking for a normal reciprocal, it'd be like for 3, it'd just be 1/3.
Here we go. Copy this example down. Example number 1 on your Cornell notes, please. Example 1. And it has, let's see how many lines we got. How many equations? We got 1, 2, 3, 4 equations. Copy that, please. All right, so first we're going to identify which lines are parallel, okay? So I want you to write this underneath. I want you to write underneath, I want to write blank, and then 2 lines like this, and blank. And what I want us to fill is that what equation, that's what we're going to write right here, what equation is, this is a symbol for parallel. What equation is parallel to what equation? So check this out. I'm going to look at them. Step 1, from our steps, let's see, what does step 1 tell us? Solve for y and write the equation in slope-intercept form. Let's see. Is this all for y? Yes. This one? Yes. This one? Yes. And this one? Yes. Okay. So I'm going to start with this one. I'm going to write it right here. Y equals 5/3 x minus 2. In order for this one to be parallel to another, what are the 2 things that it should have? The same slope, different intercept. So I'm going to scan this, and let's see, is this one the same slope? No. How about this one?
Yes.
Yeah, so therefore my second one, the other equation that's parallel to this one is y equals 5/3 x plus 4. Do they have the same slope? Yes. Do they have different intercepts? Yeah, so these 2 are parallel. Okay. All right. So now let's look at these 2 equations that we have left. And I'm going to write this, blank, parallel, blank. Let's see if these 2 are parallel to one another. Look at this. Don't say it out loud. And think about this question. Do they have the same slope and different intercepts? Don't say it out loud. Think about it. Do these 2 have the same slope, different intercepts? Who sees that they do have the same slope? Slope is 1, isn't it? Coefficient of 1, coefficient of 1. What is the y-intercept of this one?
0.
0. And what is the intercept of this one?
1.
Plus 1. So are they different intercepts? Same slope? Yeah. So therefore, y equals x is parallel to y equals x plus 1. And we're done. Copy that, please. All right, so both of these were parallel. Let's go to example 2. Example 2. Copy this, please. We got identify which lines are parallel. Y equals 2x minus 3. Y equals negative 2/3 x plus 3. 2x plus 3y equals 8. And y plus 1 equals 3 times x minus 3, close parentheses. Copy that. So let's go over our steps again. Let me go back. First step, solve for y. So let's see. Is this one solved for y?
Yes.
Yes. How about this one?
Yes.
Yes. How about this
No.
one? No. We need to solve that one for y. So therefore, in order to leave y by itself, what do? Subtract 2x, subtract 2x from each side. All right. So we're left with 3y equals negative 2x plus 8. All right. So are we done with solving for y? No. We need to divide by 3. Divide by 3. We're left with y equals negative 2/3 x, right? Plus, and I can leave the intercept in fraction form also, 8/3. Okay? So this one's solved for y. Let's look at the last one. Is this last one solved for y?
No.
No. We still have some stuff here and some stuff here. So let's distribute this. This one becomes 3x minus 9. Bring down the equal sign, the 1, the plus, and the y. We need to get rid of this 1. So what do?
Minus 1.
Minus 1 minus 1.
Y
We're left with y equals 3x
minus 10.
minus 10. And now it's solved for y. So now, with that said, I'm going to write here blank parallel to blank. What line is parallel to what other line? Think about it. Don't say it out loud. start with this one. Is there another that is parallel to that one? And then from there, this one, and then that one, and then that one. Okay, talk it over with your neighbor, see which ones are parallel. All right, let's see. Tammy, what you get? Y minus 2/3 x plus 3 is parallel with y equals negative 2/3x plus 8/3. Let's see. Do they have the same slope?
Yes.
Do they have different intercepts? Yes. So therefore that is correct. So this one with this one. Look at the last two. Is this one parallel to this last one? No. Tell your neighbor why not. Why aren't this one and this one parallel to one another? This one and this one, why are they not parallel? So I heard some of you say because they don't have the same slope. That is correct. That's the first thing that you should notice, and we're done with that. Are we there?
Yes.
All right, copy this next one down, please.
So if it's not the same, if they're not parallel, you just don't write it down?
That's it. Yeah.
What do? Do you have to graph at all on the...
Oh, very good question. For this one on your graph paper, example number 3, copy these four equations, please.
You're 5 minutes. Calm down.
Here we go. Example number 3. By looking at it, I'm going to label these 4 equations. I'm going to label this one A, B, C, and D. Tell your neighbor, turn to them, let them know which 2 equations are parallel to one another. You guys said that A is parallel to B. Is that correct? Do they have the same slope? Yes. Different intercept? Yes. Let's graph this. I'm going to graph the first one in blue. What information do we need? We need the y-intercept, which is 2, which is right here. We need a slope, which is 2/1. So that means from here I go 2 steps up, 1 to the right, 2 steps up, 1 to the right, 2 steps up, 1 to the right. The run always tells us to go to the right, never to the left. Always to the right, never to the left. You graph your line, and I'm doing that in blue. And I'm done with that one. Okay, I'm going to graph the next one in red, this one. So I need my y-intercept, which is at 1. The slope is the same. That means it's 2/1, 2 steps up, 1 to the right, 2 steps up, 1 to the right, 2 steps up, 1 to the right. And I graph my line in red. They look almost like they're going to intersect, but they're not because they have the same slope. Next, I'm going to graph the next one in green, this one. This one doesn't have a slope, does it? No, but it crosses at -4. -4 is down here. All right? So if it doesn't have a slope, check this out. Everybody look up, please. I'm going to rewrite this one down here. Y equals 0x minus 4 because it's missing the x, isn't it? So if the slope is 0, we already know what that looks like, and it's crossing at -4. Therefore, my line should look something like this. Everybody with me? 0 slope passing through that point. Therefore, and another way of looking at it, when we saw vertical and horizontal lines, we just draw a line going through -4 because it's y equals -4. So therefore, the last one I'm going to do in black. If it's let's see, it's crossing at 1 of x. Here's 1 of x. And it doesn't have the y information. This one, it was y, and it went through that number. So this one is x going through that number. So that looks like this. Do you guys see it? So now, do you guys notice that these last 2 are perpendicular? So therefore, I would write this. Everybody look up. Line C, and this is the symbol for it perpendicular. is perpendicular to line D. It's an upside down C, yes. Line C is perpendicular to D. And why is it an upside down C? Because if I do a little box here, that's a 90-degree angle. Okay? On this next one, pay attention, please. You're going to get an example such as this one. Everybody look up. Pens down. Stop what you're doing. They're asking us to write a line, an equation. To write an equation, we know we need y minus y1 equals m times x minus x1. Remember that?
Yeah.
Do they give us a point to substitute into the x1, y1? Yes.
Oh, yeah.
Do they give us a slope?
Yes.
No, they don't. But they're saying that the line that crosses through there is parallel to this one. What do we know about parallel lines? That they have the same slope. So therefore, what information I'm going to substitute for the slope?
N equals 3x.
3. So therefore, now I have this information. The 4 goes here, the 10 goes here, and everything else you know what to do, right?
Yeah.
All right. So for homework, we're doing pages what? 314 to 317, numbers 1 through 59 odd. Oh, every other odd. Have a good one, guys. I'll see you guys tomorrow, if not on Monday. Enjoy your homework. Bye. Yes. No.